Well, howdy. Welcome back. Welcome back to trigonometry. Today we're going to cover some really neat stuff, really useful stuff. And actually the next couple of days we'll be covering everything you ever wanted to know, more than you wanted to know, about graphs of these functions, the sine, cosine, tangent, etc. Okay? You know what? Before we cover the new stuff today, my cameraman Sam here asked if I could go over some homework examples from last night's stuff. So let's do that real quick, okay, just so you see what's going on, okay? They're going to ask you, I remember in the homework they asked me, which quadrant? Remember the quadrants? Quadrant 1, Quadrant 2, Quadrant 3, and Quadrant 4. Which quadrant, for instance, is 175 degrees? Okay, let's see, 175 degrees is almost 180, okay? So it's going to be in Quadrant 2, okay? Negative 210. Negative 210, we're going to start here and go around. That's 180, and I want more. I think I'm going to end up in Quadrant 2 in that one too, okay? 800 degrees. Now what am I going to do? I've got to go around, I've got to go around and around and around and around and around. Let's see. I've got to go around for 360, then around again, that makes another 360, makes 720. How many more do I have to go? 720, I need 80 more, so I'm going to end up in Quadrant 1, okay? And that's where 800 degrees ends up, okay? Negative 460. Well, we're going to go backwards. We're going to go backwards 360, and now I have a negative 100 more. Negative 100 more is going to put me just past there. I'm going to end up in Quadrant 3. Okay, you get the idea what they're wanting you to do there? Okay, let's talk about some coterminal angles. They're asking you for coterminal angles. Okay, they want 2 positives and 2 negatives. There's a million of them, so they just want 2 of each. Okay, give me a coterminal angle with 40 degrees. Well, a couple ways to do this. Let's get the 2 positive ones. Take your 40 and go 40 and go 360 more. Okay, so 360 plus 40. You'd end up at the same place. 400 degrees is the answer, is one coterminal. What if you go around twice? Okay, you're like a diver. You go 40 and then 360 and 360 more. Okay, that's a lot of degrees, but 760 is coterminal with 40. Okay, now if we want to go backwards, we could go to 40 and then go backwards 360. So what you'd be doing is 40 minus 360, and the answer would be one of a negative coterminal angle with 40 would be negative 320. Okay, what if we go backwards twice? Okay, go 40 minus 360 minus another 360. Well, you're getting dizzy now. Minus 680 is another answer. Okay? Look at a quick another example of that. What is this angle here? Now that is a negative angle, negative 120. Okay? Well, I could end up at the same place by going negative 120 and then going 360 in the positive direction. So add 360 to negative 120, and 240 ends up at the same place. Okay? Positive 240. If I go around twice, okay, so 360 plus 360, and then take the minus 220, I get 600. Okay, could have said 240 plus 360 there. Okay, what if I go in the backward direction, negative 120, and then backward another 360? Okay, and I'm like turning around negative 120 and more. Negative 480 is the answer. Okay, and if I go backward 2 360s from the negative 120, negative 120, turn around again, negative 840 is the answer. Okay, so these are some coterminal angles. Okay, then they ask you to find the 6 trig functions. I think they're trying to get you to memorize these 6. Remember I told you to do that before. Of this angle, okay? Well, the critical thing here is the signs, I guess. They're giving you that x is negative 12, and basically the adjacent leg, and the opposite leg of this angle is negative 5. Okay? What is that? Well, you have to figure that one out on your own. What do you use? You use a Pythagorean theorem. Remember a squared plus b squared? A squared plus b squared equals c squared. So I'll go negative 12 squared plus negative 5 squared. What do I get? I get 144 plus 25. And I take the square root of all that. 144 plus 25 is 169. The square root of 169, you know you're right because it comes out exact, is 13. So now all I got to do is put the right things in. Okay? For instance, for the sine is the, you got to remember, the sine is the opposite over the hypotenuse. So the opposite of this angle would be negative 5 over 13, which would be the hypotenuse. That's the answer. Okay? Good enough. Cosine is the adjacent over the hypotenuse. is negative 12 over 13. The tangent is the opposite over the adjacent. So that's going to be negative 5 over negative 12. Probably the better answer would be 5/12, okay, because we cancel out the negatives. The cosecant is basically the reciprocal of the sine, which is the hypotenuse over the opposite, okay, 13 over negative 5, or negative 13/5, either one. Okay, the secant is the reciprocal of the cosine, 13 over negative 12, okay, hypotenuse over adjacent, or negative 13 over 12, either one. And the cotangent is the reciprocal of the tangent, 12 over 5. Okay, negative 12 over negative 5, but the negatives are going to cancel, remember, so we'll get 12 over 5. Okay, then they have one more kind of problem that I think they want you to do, is find not the trig functions, but the sines of the trig functions. The sines of the trig functions for 340 degrees. Well, where is 340 degrees? 340 degrees is going to be all the way around, almost to 360. Okay? So the important thing is, what quadrant are we in? We're in the fourth quadrant, so x is positive and y is negative. That's where, for all those problems, you got to care. That's what you care about. Okay? And the hypotenuse is always positive, remember, because Pythagorean theorem, you're going to square it to get it, so it's always got to be positive. Okay? So the sine is going to be the opposite, negative y over the adjacent, no, over the hypotenuse, negative over positive. The sine is going to be negative. That's all they want, is the sine of it, whether it's plus or minus. Okay? The cosine is going to be the adjacent over the hypotenuse, which in this case is a plus over a plus, so that's going to be a positive. The tangent is going to be the opposite, which is the negative y, over the adjacent, which is the positive x, which is a negative over a positive. That's going to end up being negative. 3 more, hang in there. Cosecant is, let's see, what is the cosecant? The hypotenuse over the adjacent. No, the hypotenuse over the opposite. The hypotenuse is positive in this case, and the adjacent, and the opposite is negative. So we've got a plus over a minus, and we've got a minus. The secant is the hypotenuse over the adjacent. Hypotenuse is positive. The adjacent is positive. So we end up with a positive divided by a positive. We get a positive answer. And lastly, the cotangent in this case is going to be the adjacent divided by the opposite. The adjacent in this case is positive, positive x. The opposite is negative. So a positive divided by a negative is going to give me a negative answer. And those are all the kind of problems. You're going to need to do that, to know this kind of stuff, to do the graphing, which we're going to do next. Before we do that, let's talk about the earlier graphs, so just kind of place a seed in your brain as to what we had done before, okay, and what hopefully you already know, okay. If I wanted to graph a line, just a plain old line, I'll give you an equation that's a line. Y equals 2x minus 1, okay. One way to graph that line is to get some points, okay. Let's make a chart on that bar. Come on down, come on down. Hey, okay, let's make a chart. And let's put in, I'm not going to put in like square root of 78. Let's put in an easy point. How about 0? Okay. Okay, now if I put in 0, what I'm putting it in for is x. Okay, and I'm going to get a point, which is a pair of numbers. 1 point is a pair of numbers. So if I put in 0, let's see what I get. I put in 0 for x. 2 times 0 minus 1. 2 times 0 is 0. Okay, so y will be negative 1. Okay, so in that case, y will be negative 1, and I'll have the point 0, negative 1. Let's plot that bad boy. There it is. Okay, go over none and down 1. Okay, let's do another one, because I need a line. I need to find out where this equation apparently forms a line. Let's put in another point. Let's put my next easiest point is 1. Okay, putting in 1 for x, I get 2 times 1 minus 1. Known downtown is 2 minus 1. This is pretty easy. Y apparently in that case is 1. Okay, let's bring that. So I got another point. That ordered pair 1, 1. Let's graph that bad boy. Come here, come here. Okay. 1, 1. Okay, now you already know where the line is, but you know I always put 3 points just in case I screwed up. Not that I ever do that. Okay, so let's put another. I'm going to act like an Einstein. I'm going to put in. I'm going to put negative 1. Okay, let's see what happens. See if hopefully if it lines up, I know I'm hunky dunky. Okay, 2 times negative 1. That's negative 2. Then subtract the 1. I'm going to get negative 3. Ooh, is that a good point? Negative 1, negative 3, go back 1 and down 3. Where does that end up? There's your boy. So now you could have plotted way more points, but really see this line as a collection of all the points that are in the equation. Okay? Now, what else have we seen before? How about, that's a line. My mother can do a line. How about, oops, I forgot to tell you. I need to tell you about the domain and range. Remember what the domain of a function is? The domain is the collection of all possible x's. See how we were putting in x's? The domain is all the x's, all the numbers that you can put in, if you would. And then another word we're going to use is range. That's all the answers that you get out, or all the possible y's. Now, in this case, the domain is, there's like a fancy language for this, x such that x is an element of the real numbers. In other words, all x's are good. Okay? And the range, basically all y's are good. Okay? So it's a large collection. That's not always the case, and I'll give you an example of that right now. Okay? Let's look at a fancier one. Let's look at the graph of a curve, known downtown as a quadratic. Okay, we'll do a simple one, y equals x squared. Remember these bad boys from algebra? Let's do some more points. We'll have to do more than 3 points in this case, though. We'll do our favorite guy, 0. 0 squared, let's see, that'll be 0. And I'll plot that. I'm going to go a little bit faster now. I'll plot that point, 0, 0. Let's put in 1. That'll be 1 squared. And I get the point 1, 1. It's starting to look like a line, but wait a minute. Let's put in negative 1. Negative 1 squared is 1. So if I plot that point, negative 1, 1, doesn't look like a line anymore. Let's put in 2 more, just to be fancy. Put in 2. If I square 2, I get 4. Where does that end up? 2, 4, the point 2, 4, over 2 and up 4, bam. Okay? One more, just to be fancy. Negative 2. Okay, let's see. That's going to end up right there. So you can see, I hope, where the curve's going to be. If I plotted all the points, they'd end up being right there. Okay, now let's talk about the domain, the collection of all x's, and the range of this function. It is a function. Okay, the domain of this is the collection of all x's. What x's can you put in? Well, you can put in whatever you want. You can get as high as you want. Okay, you can get as negative as you want, going all the way to the left, and you can get as positive you want, going all the way to the right. Okay, so really, we have the same deal there. Okay, but if you think about it, when you square something, you can only get a positive answer. In this case, then, the outputs, the collection of all y's, known downtown as the range, is going to be a little bit fancier. It's going to be y such that y is greater than, and it really should be y is greater than or equal to 0. Okay, because it can be 0. But it can't be negative because you can't get a negative by squaring. So that's the range in this case. Okay? Well, that's the kind of basics of graphics that you kind of already know. How's that related to what we want to talk about now? It's our new stuff, the graphs of trigonometry functions. Okay, well, before we do this, we're going to be putting in points, and I don't want you to think I pulled these points out of my backside. Okay? So let's just remind you some of the answers to some of the trig functions. For instance, in this triangle, I got the answers 1, 1, and square root of 2 because it's a 45, 45 triangle by the Pythagorean theorem. Remember we covered that before. Okay? The square root of 2, just approximating it, is 1.414. Okay? Trust me on that. Okay? So what would for instance, the tangent is going to be the tangent of 45. I'm seeing my 45 degree angle. The tangent would be the opposite, 1, over the adjacent leg, 1. So the tangent of 45 is 1. Okay? The sine of 45 is going to be the opposite, which is 1, over the square root of 2. I should say 1 over 1.414, and that comes out to 0.707. Okay? I'm not just making it up. Okay? And the cosine is the same thing, adjacent over hypotenuse, 0.707. So, you know, when we see this 0.707 later on today, hopefully you'll, just plant a seed kind of a thing at 0.707. You can just pull that out of something. You really got it from doing something divided by something. Okay? And that's going to be all the multiples of 45 kind of a deal. And let's look at the multiples of 30 and 60. Let's look at 60, for instance. Okay? In a 30, 60, 90 triangle, you may remember, the ratio is square root of 3, 1, and 2. Okay? It's kind of... And the square root of 3 is 1.732. Okay, you could put it in your calculator, but trust me on it. Okay, so the tangent of 60 now, what's opposite the 60? The 1.732 divided by the adjacent 1 is going to be the square root of 3. It's going to be, 1.732 over 1. Okay, so remember that number. Don't memorize it. You don't need that. But, just so you don't think I'm making it up or anything. The opposite over the hypotenuse, which will be the sine, would be the 1.732 divided by 2. Well, half of that is 0.866, I promise you. Okay? And the cosine would be the adjacent over the hypotenuse of 60. So the adjacent is 1. The hypotenuse is 2. 1 divided by 2, even I can do that, is 0.5. Okay? So it's not like we're making these up. Okay? So remember those numbers. Those are the only crazy numbers we're going to get. Okay? Now there's some other numbers that aren't hard numbers, but they're kind of hard to get the idea of. Okay? When we get to remember from last time, we get to larger than 90 degrees kind of a thing. We are going to look in graphs in larger than 90. Okay? So when we do that, we think of this as looking at, in standard position, looking at a graph, okay, where the angle itself, in this case, I have it listed as theta. The angle itself is based on a point that is xy, meaning that the tangent is going to be the opposite, which is y in this case, divided by x. Okay, so get used to the tangent being whatever y is the value for that point divided by x, opposite over adjacent. The sine is going to be opposite over hypotenuse, which is y over 1. So basically y over 1, it's going to be y. The sine is going to be y. Okay, and no matter where we are, it's going to be whatever y is. And the cosine is going to be x, because the cosine is the adjacent. The adjacent leg in this case is x. Now where are we getting the 1? Remember, this is a unit circle. Okay, now we're going to go to crazy places. Right now we're in quadrant 1. What if we go to quadrant 2? Okay? Still the same deal. The tangent is whatever y is over x. Well, in this case, x is negative. So we're going to get the same answer, except it's going to be negative of it. So when you see a bunch of negatives, you say, that's because it's in quadrant 2, okay, because x is negative. Okay, and the sine, is the sine going to be negative here? The sine's not going to be negative because the sine, which is y isn't negative in the second quadrant. Y is up, okay? Now, the cosine is going to be negative because the cosine is based on x. As we told you before, the cosine is going to be negative in the second quadrant. Okay? And in the third quadrant, the third quadrant, they're both negative, right? Negative x and negative y. So the tangent will have the two negatives, but they'll cancel out. Okay? So the tangent's going to end up being positive, some positive crazy number, but it'll be positive. Okay? The sine, let's see, if they're both, the sine only cares about the y. Okay, the sine, the opposite being the y. So the sine will be negative in the third quadrant, as will the cosine, because the cosine only cares about the y. There won't be any cancellation in that case. Okay, I'm going through this real quick. We're going to slow down a little bit later, but I just want to get all through this. So let's do one more quadrant. Okay, quadrant number 4, where let's see, in quadrant number 4, we go to the right and down. So x is positive, y is negative. So the tangent, the opposite in this case, will be negative, the negative y over x. So the tangent's going to be a negative number. The sine's going to be, let's see, the sine only cares about the y value, so the sine will be negative. And the cosine only cares about the x value. As crazy as this is, the cosine in the fourth quadrant is still going to be positive because x still is positive. It doesn't care about y. Pay no attention to that y. Okay? So that's the deal in some crazy situations. Now, a couple more crazy. What if we're not in a quadrant at all? What if we're right on an axis, like 0 degrees? Okay? We're still using y and x. Still using y and x. What is that point? What is that xy point? Well, let's see. We went over, because it's a unit circle, we went over 1 and up none. So we're still going to use the same thing. So the tangent, let's see, will be the y over the x, which will be 0 over 1. So the tangent of 0 degrees is 0. That's believable. I can believe that. Okay? The sine of 0, which is the y over the hypotenuse, is, or just the y, as we said before, is going to be 0. Okay? And the cosine at this point is going to be, which is only x, which is going to be 1 in this case. So at 0 degrees, we get these crazy numbers. Okay? Okay? Where's another place on an axis that might get crazy? How about at 90 degrees? Okay? Once again, what is this point that we're talking about here at 90 degrees? It's xy, but what is it? Well, it's the point 0, 1. Okay? The tangent will be y over x. What's y over x? Here's where it really gets crazy. Okay? 1 over 0. 1 over 0. What is 1 over 0? 1 over 0, some people would say it's undefined, and it kind of is undefined, okay? But other people would say it's infinity, and that's what we're going to talk about today, it being infinity, okay? I'll get into that a little bit in a second. Let's see what the other two functions will be first. The sine will be, let's see, the sine is the y value. So the sine is 1 over 1. So sine of 90 will be 1. 90, no downtown, is pi over 2, remember. Okay, and the cosine will be the x value. What's the x value right there? The x value is 0. Okay, so the cosine of that will be 0. Now let's get back to this infinity nightmare, okay? How do we get infinity from 1 over 0? Okay, some people do, and you're going to need to be able to draw infinity, say on a graph, because that's what we're looking at. Well, think about 1 over 7. 1 over 7, 1/7, if you look at it as a decimal, is 0.142. Okay, big deal. 1 over 2 is 0.5. 1 over 1 is 1, of course. Okay, now let's stop for just a second. As these numbers, the 7, the 2, the 1, the bottom numbers, I have them in red. I don't know if you can see them as red. As these numbers here, okay, get smaller, what's happening to the right side numbers, the 0.142, 0.501? They're getting larger. Okay, let's make it even smaller. 1 divided by 0.1. That bottom number is real small. You know what that number gives me? 10. I'm getting bigger. 1 divided by teeny-weeny 0.1. What does that give me? It gives me 100. So the smaller the number I divide by, the larger the answer I get. What if I divide by the smallest number I know? Well, how large can you get? And that's where I'm going to get infinity. Okay? Now, it's one little crazy. What about if I divide not 1 divided by 0? What if I divide -1 by 0? Well, that would be infinity, but it would be negative infinity. Okay? So we're going to be looking at this. Now, if infinity is heaven, what's negative infinity? Well, think about that. It's H-E double toothpicks. Okay? So think about, when we look at a graph, think about negative infinity. Where's that going to be down? It's down past purgatory. Okay? So we'll come back to that in a second. Okay, let's look at a couple more axes, because we're going to need to know the answers for this. When we're right at 180 degrees, the answers for these functions, we're still doing the x, y. It's simple if you've memorized your functions. Okay? At this point, we're looking at the point -1, 0. We went back 1 and up none. Okay? So what is the tangent? Y over x. What's that going to be? Y over x is 0 over -1. Okay, so that's 0. That's a simple one. So at 180, the tangent is 0. Okay? And the sine is y. What's the y value? It's 0 at this point. Okay, so the sine of 180 is 0. And cosine is the x value. The x value at this point is -1. So we can actually have a negative cosine, okay, at that point. I think we have one more axis, right? Nope, not going to do it. Okay, so let's look at all these answers. Look at all these in radians. 0 degrees is 0 pi, 45 pi over 4, 90 pi over 2, all these things. You don't have to memorize those. Okay, and looking at the answers for the sine. We're only going to do the sine right now. Come on over. Remember that crazy number, 0.701? Okay, those came from the 45 degrees. This is all the multiples of 45 degrees is what's going on. Okay? How come these ones are negative? How come they're negative? Well, they start with 225 and 315, and they go to 315. This is the sine. Okay, how come they're negative? I'll tell you why. Okay, they're in from 225 to 315. They're in the third and fourth quadrant. What's negative in the third and fourth quadrant? Y. Okay, and that's what the sine is. Y. Okay, so that's why they're negative. So it's not like they're crazy. Okay, let's graph these bad boys. Okay. Let's see. I've marked my graph. I think it's easier, and get used to this, in radians, pi and fractions thereof, a fourth of pi, a half of pi, etc. Okay? So at pi over 4, which is 45 degrees, oops, at 0, I'm going to get 0. Okay? At pi over 4, what am I going to get? I'm going to get this 0.7 something. It's somewhere between a half and 1. Okay? At pi over 2, which is 90 degrees, what do we get for the sine? We get 1. Okay? At 3 pi over 4, what says that, 135? I'm going to go back to 0.7 again, remember from the chart, okay? And when I go to 180, I'm back to 0 again. Look, it's going up and coming down. What's going on here? Okay? At 5 pi over 4, which is about 225, I think, we're going into negative. Remember those ones went into negative in the third and fourth quadrant? Okay, at 3 pi over 2, we're getting even more negative. We go to negative 1, and guess what's going to happen now? At 7 pi over 4, we're still negative, but it's coming back up. Okay? And at 2 pi, which is 180 degrees, we're back to 0. Okay, so this thing kind of looks like a roller coaster. That's what the sine graph looks like. Let's fill in a couple more points, just like we did with the line. Let's fill in a couple more points. Let's do the multiples of 30. Okay, 30, 60, etc. Okay, as radians, they look like this. Okay, because for instance, 1 pi we know is 180 degrees. So 30 degrees would be 1/6 of that, pi over 6, etc. So you're going to see a bunch of 3's here. Pi over 6, pi over 3, 2 pi over 3, etc. Okay? Don't bog your brain down with that, but what are the answers for the sine for these various answers? Okay, we'd seen 0.866 before, and we'd seen 0.5. Remember that for that triangle earlier? How come? Let's put them on the graph. Okay? For pi over 6, ooh, it fits nicely. You love that. 0.5. For pi over 3, wasn't that 0.866? It's a little bit bigger than 0.7. Ooh, that's looking good. Okay? For 2 pi over 3, that comes right back down to 0.866 again. Son of a gun. Okay? For 5 pi over 6, look at it, it's 0.5. It's fitting nicely. You love this, that this is fitting like this. Look at it. You know you're right. Okay? Putting all these in. Beauteous. Okay? Now, before we go on, I want to look at, let's go a little bit further. Let's look at coterminal angles. Okay? Like, for instance, 0 degrees is the same as 360. Okay? I've already gone around once because I went down around to 2 pi. Okay? Let's do more than 2 pi. Okay? Let's do pi plus 360 plus another 45, or 90 plus another, 45 plus another 360, 90 plus another 360. Let's keep going more and more and more and see what we get. Okay? As radians, we're getting more than 2 pi now. We're going around more than once. But neato torpedo, if you look at the right side, we're getting the same answers. Okay? Let's see what happens. If I move my graph over and go more than 2 pi, 9 pi over 4, which is like a 2 pi and 1/4. It's 8 pi over 4 and another pi over 4. Okay? I'm going to get a point up there. And if I continue on, guess what? It stays in the same pattern, coming back, going back down into negative, etc. Okay? Let me fill in the, let's go the negative direction and see what happens. Negative coterminals. What's the same as negative 45? Well, that'd be 315, positive 315. But we're going to get the same answers. See, I already had the answers on the right side. Okay? But we're going to go in the negative direction. So I'm going to get a negative 45, a negative 90, etc. Okay, let's take a look at that. What you're going to see on the graph, you're going to see them in radians, though, so don't be afraid. Okay, so negative 45 is negative pi over 4, negative 90 is negative pi over 2, etc. Okay? Let's look at these answers on the graph. These negative ones here, negative. Oh, by the way, why do those come out negative? This is the sine. Why do they come out negative? Negative 7. What quadrant are we in for negative 45 degrees? That's where we start off. Negative 45, negative 90, negative. What quadrants are we in? If we go in the backward direction, we're in the 4th and 3rd quadrant. That's where y is negative. Okay, so that's why they're negative. Okay, so let's take a look. Let's go backward. Okay, negative pi over 4, negative 45 degrees. Okay, it's going to be right there. That's what negative 7. Negative 0.7, blah, 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 blah. Okay? Negative pi over 2, that's going to be negative 90. Okay? And that ends up right there at negative 1. Okay? This is negative 135. Ends up, it's continuing in the same pattern. Pretty cool. Okay? In fact, it continues on forever. Okay? Even if we go in the negative direction. Okay? And that's what it ends up looking like, the sine curve. Now, let's talk about what's the domain and range. This is a function, okay? What's the domain and range of the sine, okay? The domain is all the possible x's. What possible x's can we put in? We put in plenty, didn't we? We can put in anything you want, basically. Okay, so that's not a problem. You can put in anything you want. So x is x such that x is any real number. Okay, the range isn't going to be such. You cannot get any answer for this. If you look at the levels of y, this graph only goes as high as what? As high as 1, and as low as -1. You cannot get 2. No matter what you put in, it's going to go up and down, up and down, up and down. You cannot get that high. Okay? So the range is basically going to be all the y's anywhere between -1 and 1, inclusive. So y greater than or equal to -1 and smaller than or equal to 1. Okay? That's the deal there. Okay? So that's the sign. Pretty cool. Okay? Very different than a quadratic or a linear function. Okay? Now we're going to do the cosine, but I want to warn you about this. Remember, the cosine is x. Okay? The cosine is going to be your buddy x. So think of x as being positive to the right and negative to the left. Okay? Let's think about this. Let's go look at our cosine. Okay? If we have we're going to do our multiples of 45 here. And there's our radians. We've seen them before. Okay, the radians is just another way of writing. For instance, 90 is pi over 2, etc. Okay, if we do the cosine of these angles, we're going to get answers like 1, 0, 0.701. Okay, we're still going to get them. Why are these negative? Remember the cosine is x. Okay, the cosine is x over 1, or adjacent over hypotenuse. Hypotenuse being 1 in this case. What are we looking at here? We're looking at 135, 180, and 225. Where are those angles? Those angles are in the second and third quadrant. What's negative in the second and third quadrant? X. Okay, they're to the left. Okay, so that's why they're negative. So it's not crazy here. Let's look at these on a graph. Okay. Now let's see. At 0, the cosine is 1. Remember that? That's how it's different than the sine, by the way. The sine starts off at 0. The cosine starts off at 1 at 0. Okay? Okay, at pi over 4, at 45 degrees, it comes down to 0.7. Okay? At 90, what happened to the cosine? At 90, it's 0. Okay? And at 135, 3 pi over 4, it goes into negative. Why did it go? Remember, it went into negative because we were getting into the second quadrant. That's where x is negative. Okay? And it's getting even more negative. Okay, when we're at 1 pi, that's 180. Okay, what do you think is going to happen now? 5 pi over 4. Guess what? It's still negative, but it's coming back up. It's coming, come on back up, come on back up. And by the time we get to 2 pi, we're back at 0, really, you could say. We're back up at 1, because 2 pi, 360, you've gone all the way around, kind of a deal. So it's as if you're at 0. You get the same answer. Okay? Let's do a couple more points. Okay? Let's go in the negative direction for the cosine. Okay? 0 being the same as 360. Negative 45, going backwards 45, is the same as positive 315. Okay? So we'll go in the negative direction and do a couple of these things. I'll do a lot of them real fast. Okay? Let's see the answer we get for the cosine for these babies. We're still getting 0.7s. That's good, because these are multiples of 45. Okay, what about these? Let's see what they look like. Okay, I'm going to do 0 again. I'll start off with that. Okay, now we're going to go backward. Okay, negative 45 will give you the same answer as positive 315, 0.7. Okay, negative 90 is going to give you the same answer as positive 270, which is 0. Okay, and look at what's it doing. It's doing the same thing that the sine did. It seems to be fluctuating, okay, going up and down, up and down. And that's what it looks like, okay, the cosine. Note the difference between, they look a lot alike if you look at them for 5 seconds or 1 second. Okay, note the difference between the cosine and the sine. The cosine starts off at 1, okay, at the axes, it starts off high and the roller coaster goes down, whereas the sine started off low and went up. Okay? Let's talk about the domain and range of this. Okay? The domain is going to be very similar. The domain is going to be any number. You can put any number you want. Okay? And the range is going to be, let's see, what are the possible answers we can get out? Very much like the sine. Okay? The can go as high as 1 and as low as -1. So here again, our range is going to be all the numbers between -1 and 1, okay? Inclusive. I mean, you can get as low as -1, so it's y is greater than or equal to -1, and y is less than or equal to +1. Okay, so that's the range of the cosine function. Okay? Okay, now, you know what's coming up is the tangent. So let's look at some crazy parts of the tangent. Okay? When it's 0, okay, this point, xy, the 1, 0, the tangent is 0 over 1. So it shouldn't surprise you when we go to graph this thing. It's going to start off, the tangent, it's going to start off at 0. Okay? That's not too hard. The opposite over adjacent, or y over x, in this case, is 0 over 1. Okay? Well, what about it? Here's where it gets screwy. At 90 degrees, the point that we're looking at, the xy point, is 0, 1. Remember what we had talked about before. Y over x in this case is 1 over 0, which is undefined, but we're not going to say undefined. We're going to call it, what did we say undefined was? Infinity. My son would say infinity. Okay? It's up in heaven. Okay? Unless it's negative infinity, then we know where it is. Okay? So don't think I'm going crazy when we start graphing infinity. Okay? Because at 90, it's going to be infinity. And guess what? At 270, all the way down here, it's going to be negative infinity. Okay? So at 90 and 270, we're going to have trouble. Okay? Let's take a look at this. Oh, I wanted to show you 180 also. Okay, at 180, it's not a problem. Okay, at 180, what it's going to be, the y over the x will be 0. It'll be 0 again. Okay, so that's not a problem. It's these the 270, which is a problem. What's that going to be? Y over x is going to be -1 over 0. It's going to be negative infinity. Okay, so 90 and 270 are going to be the troublemakers. And of course, any multiple thereof, like any coterminal angle with 90, any coterminal angle with 270, like 90 plus 360, 270 plus 360, etc. If you go around 7 times and you end up at 90, you're still in trouble. Okay, you're still going to be at infinity for the tangent. Okay, so we'll see what happens with that. Okay, let's look at our answers and we'll start graphing them. If we have 0, these are all the multiples of 45. Okay, and in degree language, if you would, and in radian language. A tangent looks like a bunch of zeros and ones, and it is. Okay, it's a bunch of zeros and ones. There's a couple. There's a -1. Why is that negative? Let's see. Why is that negative? At 135, we're in the second quadrant, and y over x, it's 1 over 1, but at that point in the second quadrant, x is negative. So we've got a positive divided by a negative, so we get a negative answer. Okay, what about this guy? The 315, if you go all the way around, let's see, 315, you're almost all the way around to 360. You're in the fourth quadrant, so you're a negative y divided by a positive x. So we've got a negative divided by a positive. There we're getting our a negative answer. And don't forget your troublemakers. Infinity, where's that? Put that in your brain. That's at 90. And negative infinity is at 270. How are we going to graph that? Okay, well, let's see. Okay, let's graph this bad boy. At 0, the answer was 0. Okay, that's right. At pi over 4, which is 45, it goes up to 1. At pi over 2, which is 90, what do we do? How are we going to symbol that? What am I going to do? Run upstairs? Oh, there it is. I'll put a point and I'll put an arrow. You just have to pretend that it's way up in heaven. Okay, that's an angel point. Okay? Okay, and this one, 3 pi over 4, the 135, that's going to be -1. Okay? 180, 1 pi, we're back to 0 again. And 5 pi over 4, which is that, let's see, that's 225, we're back to 1 again. And 3 pi over 2, which is 270 degrees. Remember that troublemaker? He's down in HE double toothpicks. Okay, he's down in negative infinity. Okay, and that's what you're kind of looking at. And if we continue on, we're going to get a pattern like this all the way through 360. 360, we're back to 360. Known downtown is 0. We're back to 0 again. Okay, That kind of looks weird. How am I going to draw a line on that? Okay. Well, if I fill in a couple more points, we did the multiples of 45 there. Let's do the multiples of 30, the 60. The answer's here. Here's a bunch of decimals, okay? Remember those .577 and the 1.732? Okay, well, let's just fill them in, okay? Trust me. Okay, if we put those in, have a couple more points, put them in real fast. That's where they go. Here we go. Boom! That's what it looks like. Well, now you can connect the dots. You can connect the dots. You don't just get one line, though, because we've got this infinity situation going on. We've got negative infinity and positive infinity. When you graph the tangent, it looks kind of like that. I'm going to connect the dots. It ends up looking like that. Okay? Now, I got to tell you, that's what the tangent looks like. You're not going to use the tangent. A lot of math teachers would kill me for saying this, but you're not going to use the tangent as often as you with the other ones, because this is not does not show up that often in nature, because we can't draw it. We can't draw up to infinity. Sine and cosine is going to show up all the time, though. Okay? The domain of this, what can we put in? We can put in anything but. What could we not put in that would cause trouble? 90, remember that, and 270. 90, which is pi over 2, okay, and 270, and any coterminal angle with that. Well, the fancy way of saying that is any x such that x isn't pi over 2, or 90, plus some number, some integer, times pi. In other words, 1 pi plus 90, that would be 270. 2 pi plus 90, that would be 90. Okay, that would be coterminal, that'd be coming back, etc. 3 pi plus 90, anything, as long as you're not in, now you can do 180, which is a multiple of 90. You just can't have a multiple of pi plus pi over 2, okay? That's what's going on. In other words, you can't end up at 90 degrees or 270 degrees, or it won't know what to do. So that's the domain. The range, what are the possible heights or depths of this graph? Well, it goes as high as you could go, okay? So the range is easy. The range is everything. Anything, any y. You have all kinds of numbers that come out of that, okay? So that's what's going on there. So that's the range of this function tangent. Okay, I hope I didn't scare you, because now we're going to try doing it a little bit easier. We'll do it with a calculator. Before we start with the calculator, you're going to have to get your calculator out. Okay, I hope you have it out. You should have it out every class, by the way. Okay? Let's look at, there's going to be some new buttons we're going to use. Okay, let's look at some buttons, the ones you're going to need to know. The y equals button, just find it. I'll show you what it is for in a second. Okay, the y equals button, you probably used that before. I hope you did if you ever graphed with a calculator. Okay, note where that is. Okay, now this button, I call it the variable button. It's the x, t, all those, it's called the x button, but we'll call it the variable or the x button is what I'll be saying. So note where that is. Okay. The graph button, when we finally, it's like a command. It's like, hey, graph, okay? Look for that button. You're actually telling once you put in the specifications, you're actually telling the calculator to do the graph. Go ahead and do it, okay? The zoom button we're going to be talking about, okay? You can be too close or too far away from something, and we'll be playing with that button. So find that button. It's up on the top there. I'll assume you know where that is. Okay, and the parentheses. We're going to need to mess with parentheses again. Okay, ugh. Okay, so just note where they are. They're kind of in the middle of the calculator. They're the left and the right. Okay, turn that bad boy on, and I'll tell you what. Now, don't be one of those get-ahead dirtballs. Okay, let me do it first, and you watch it, and then I'm going to give you a chance to do it. Okay. Okay, let me go over to my calculator and we'll try this. Okay, I want to graph the sine of x. Okay, let me turn it on. Okay, let's see. Now the first thing I'm going to do is hit my y equals. Okay, so I'm going to put the function that I want in. Okay, y equals. Now there's a function there from somebody else, the last person that used this calculator. So it may be there, it may not be there for you. So if I want to get rid of that, there's a button called clear, as you know, and I'll hit the clear button, and bammo, it's out of there. Okay? Now, I'm going to put in sine of x. Sine, it doesn't have of x, because it doesn't know. I may be tune in later when we do the sine of 2x, or the sine of 70x, or something like that, or x plus 5. So it didn't put in the x for me just yet. The way I put in the x is I hit the variable or x button. So I'll do that right now. Okay? Now you don't actually, in this case, have to hit the right parentheses, but I want you to get used to doing it because we're going to have to do it eventually. Okay? So hit the right parentheses. That's what I'll do. I'm going to give you a chance to do it in a second. Okay? I hit the right parentheses, and that's what I see on the screen. Okay? Now, how do I tell it? Graph. I want to tell it to graph. Okay? I'll hit the graph button, and something's going to happen. But you know what? I'm not too happy. That doesn't look like what I got before. That doesn't look like that. Well, the problem is, and this is a problem sometimes, is that it's zoomed improperly. Okay? And basically what this calculator screen is it's a giant camera, is what it is, a little teeny camera. Okay? Because remember that the sine curve goes on forever in that direction and forever in that direction, so it doesn't know, you know, how close or how far you want to be. Okay? And if you want to, I mean, you could be too close. I mean, I could say, look at my face. Okay? That's going to be hard to do. Okay? Or you could be too far, obviously, right? I say, look at my face. You say, look, your face looks great right now. But that's not what we want to do. Okay? We want to be at the perfect zoom. This one's in too close. Okay? So it's a simple solution to this for trigonometry functions. Okay? I'm going to hit the zoom button. Okay? And it gives me all the possible zooms. And you know what you want? You want your buddy zoom trig. You see it down at 7. Now, you people that are too lazy to cursor down, I'm going to cursor down to show you where it is. Okay, could just hit 7, but I'm going to cursor down and hit enter. And look at this bad boy. Can you see it graphing? Okay, and what basically zoom trig is going to bring it right to the threshold at which you will get the perfect, I say perfect, you'll get 2 cycles is what you'll get. Okay, now we could be out too far or in too close, but what we'll do is just hit zoom trig every time, and you'll know you're hunky-dunky. You'll always get 2 cycles. That's a perfect graph. Okay, now look back at the graph. I want you to note that the sine curve, as you see, it starts at 0, okay, and then it goes up and works around, starting at 0 degrees. But you know the calculator is not the end all. Like on a test, it's not going to be your saving grace, because when you sketch a curve, you're going to have to tell me. Well, you know what that point is. You're going to have to tell me what these intersection points are, these critical points. Okay? I happen to know that they're pi and 2 pi, etc., but you'll have to draw that. Okay? So consider that you know, it's going to help you a little bit as to know what your picture should look like, but it's not going to be the end all. Okay? Let me give you a chance to do it. Let's go back to the screen. And what would you do? You get your calculator out. You're all set. Okay? Let's review that. You turn it on. Okay? Hit your y equals button. Find it. Okay? Now, if there's something there, I put clear in parentheses, because if there's something there, you need to get it out. But if you don't need to get it out, you know, just leave that clear alone. Okay? Okay? Now, let's see. We need to type the sign, so sine of x, or just sine. Find the sine button. Hit that, and that's what you'll get. Okay? And then the variable, hit the x button. Okay? And it'll say sine of x. Now, remember I asked you to get used to putting the right parentheses. So hit the right parentheses. You actually, as I said, you don't have to do it this time. Okay, now we're ready to rock and roll. Okay? Tell it to graph. What do you hit? You hit the graph button. And depending on whether you're happy with what you like, what you're seeing or not, you may have to zoom. Okay? If you're happy, if you're seeing the 2 cycles, okay, and once you set a zoom, you're going to be hunky-dinky. But just always be aware that you may have to hit zoom and then trig, which is number 7, okay? Or if you cursor down, you hit enter, okay? It's pretty cool, okay? You're getting on your calculator? Okay, let's get, how do you get out? How do you get out? Hit clear. That's a way to get back out, okay? Let me do the cosine, okay? See what that bad boy looks like and how different it is, okay? I'm going to go back to the calculator. Let's see. I haven't cleared yet. Okay, well, let's see. I start off with my y equals. Okay, I got to clear out the sign. Okay, so I'm going to hit clear. Get out of there. Okay, cosine, I'll hit the cosine button. I need the x, so that's the variable button, x. Okay, let's see. Right parentheses, get used to that. Now I don't hit enter, I got to tell it, enter just will move me down, much like a word processor. Okay, what I need to do is tell it to go ahead, let's go, rock and roll, let's graph. And I hit the graph button. Now this time it comes out hunky-dinky because I had already zoomed to trig. Okay, so I really don't need to zoom to trig in this case. Let's point out something though again. With the cosine, as we start at 0, here's the 0 line, what does the cosine start off? It starts at its highest point. It starts at its highest point and works its way down. Okay, and then it'll come back up to its highest point when it goes all the way around the circle to 360 again. Okay, that's a huge difference between the cosine and the sine. The sine, remember, started down here and went up. Okay? Okay, let me give you a chance to do it. Okay, let's see. What do the first thing you do? You already got your calculator on. You've already cleared out. Okay, hit your y equals. Probably have to clear out the sine because we put that in last time. Okay, and put in the cosine. Cosine of x. Oh, not of x. I have to put the x. No. Hit your variable button x. Okay. Hit your right parentheses. Get used to that. And tell that bad boy to rock and roll. Graph. Okay. Now, once again, just in case, you know, be aware. I don't want to just go over it once and then you forget and go, what's wrong with my graph? Okay. You may have to zoom it if you're not happy with it. And it's as I said, there's a simple way to do it. Zoom trig. Okay. So you hit the zoom button, and you might want to practice it now. Zoom, and then trig is number 7. Try doing it a different way this time. Hit 7. Okay. And you should be hunky-dinky. You should be seeing a beautiful graph. Okay? Okay, let's get out with clear. Okay? We have one more to do. Remember the crazy one, the tangent? Okay, I'm going to do that one. Let me try that one. Okay? Let's go over to the calculator. I still haven't cleared out this cosine. Okay, I'll hit clear to do that. Okay, let's see how I start off. Y equals, I want to do the tangent this time. So I'll clear out. I'm hitting my clear button. And I'll hit tangent. Okay, tangent, and I need the x, so I hit the variable button. Okay, right parentheses. Okay, and I'll say, hey, graph away, go crazy. Now that really is 2 cycles, if you can see it. Okay, it looks like it is more than 2 lines, but a cycle, remember a cycle starts at 0. Here it is starting at 0. Goes to, it's 90 up here at infinity, okay? Then negative infinity, we go back to 270. We don't get back to 0 until here again, okay? So that is 2 cycles, okay? Actually, we want to go back to here for another cycle. So we go from here to here as a full cycle, okay? So that's the deal. I'll clear that out. Okay, you got to try it. You got to try it. Let me give you the steps just in case you forgot. Okay, graphing. Make sure it's on. Hit your y equals. Clear out what's there. If there's nothing there, you don't got to worry about it. Okay. Tan. Hit your x. And right parentheses. And then tell it graph. And you should see a beautiful, beautiful graph. By this time, you certainly have zoomed trig, so you don't need to do that. Okay. And we can, it takes a little time sometimes to come up on the screen, okay? And then how do we get back to our normal screen? Remember the button on the right there, top right is the clear button, okay? Okay. Now the reason we care so much about these graphs is that, and we'll be covering it next time, is that many things in nature can be simulated with the sine function or the cosine function, okay? But a lot of things happen in the sine. And why do we care about things in nature? Because guess what? God made those, okay? We can't do those. We can't copy those, but we can simulate them, you know, using, and then perhaps predict the future on a graph using the sine wave of things in nature. What kinds of things in nature go in ocean waves? You can even see the ocean wave. If you graphed an ocean wave, it goes in very much like a sine wave, okay? Anything in waves. Sound waves travel if you graph them, they travel as sine waves. Okay, earthquake waves. There's something you wish you could predict. Okay, and not only predict some things, but perhaps change them. Okay, we can change light. We can change radio waves. What do you mean change radio waves? If you change radio, that's what you're doing when you're tuning in your station. You're changing radio waves. And waves, if you looked at them graphically, I know you can't see them, they're invisible, but if you looked at them graphically, they would look just like a sine curve. Okay? And they are infinite. Heartbeats, we're going to be talking about that next time. Heartbeats look just like, if you graph them, they're not one sine wave, but they're a collection of the sum, the SUM sum, of some sine waves. And think about that with heartbeats. We're listening to sound, and if you graph that sound, I'll show you next time, if you graph that sound, it forms a sine wave, and you can look at that graph and you can tell whether the person's sick or whether they need an operation, or not only that, but where they need the operation. We'll have to break open their chest and see, oh, it's your right ventricle I can see, okay? You can actually tell from the graph of the sound, which is pretty cool, okay? Even brain waves travel in some multiplication or multiple and addition of sine waves, okay? Which is cool, okay? So if you tune in next time, we're going to do some explorations of transforming the sines and cosines and tangents. Okay? We'll see what happens when we multiply them by 2 or add them to each other, or various things, and that's how we get these heartbeats and these earthquake waves, etc. Okay? Until then, I want you to do homework number 5. Okay? And if you don't know what that is, you look on your syllabus. If you lost your syllabus, go out to the home page, and you can get that syllabus. You can get the answers. Remember, out on the home page, and you can even view this animation of everything that I've been seeing. You've been seeing here on this television program. Okay, remember where that is, www.mc.cc.md.us / that's a little thing on the top left of the keyboard, Witte. Okay? Till then, till transformations next time, we'll see you. Thank you.